Okay. Can you hear me, guys? Test. Okay. All right. Good evening, first, and today, I mean, the review for my part is going to be informal, and I guess same for William. So please feel free to stop me or ask any questions. So it's going to be a few slides. We're going to go over it, and then I'm going to upload it with the recording archive, okay? And since the exam is Monday, feel free to send any emails over the weekend, Okay, so the main point is that all exam questions will be from the material I presented in the class, okay? If I didn't talk about it, I'm not going to ask you, okay? Anything that I said or I put on the slides, in the outline, is included in the exam. Stuff that you've never heard of, not included. So I received a few questions from some of you, and we're going to answer these questions, and then I'm going to give you a couple of examples of questions that I was asking. So the first question was from one of your colleagues that can we go over the pi and psi angles and stuff? Because the exam sample that Dr. Chan sent to you is from previous year, and I'm new in this university. So it was from Dr. Rossi, okay? So these are not my questions. So if you find any questions that you've never heard of, basically don't worry about it, okay?
Awesome.
Can you raise the volume a little?
Okay. Is this better?
Oh, yeah.
Like the other here. Okay. Maybe the volume. Is this better? No. Test? Okay. Yes. Okay, thank you. Okay, so I guess this will answer many of your concerns. Again, another general rule, basically, you need to understand and memorize all the stuff I told you about in the lecture. I try to be as clear as possible. Anything that we didn't talk about or sounds like, outside, I gave for an example, would not be included. Let's see. So this is one of the, another question said, can you go over glutathione and GFP and how much detail you expect us to know for the midterm? I guess I answered these questions. I told you anything I said or we put on the slide, you need to understand fully, okay? So let's see here. For glutathione, okay, what you need to know is a bioactive peptide, okay, that has 3 amino acids. From the name, glutamate, cysteine, and glycine. You need to know these, okay? Frankly, I wouldn't ask you about the structure because it's not a typical tripeptide attachment, okay? Because it's an isopeptide, basically. The peptide bond is at the terminal side chain, okay? But you need to know the 3 amino acids, obviously. An important feature that you need to focus on is something that we discussed. The whole idea is the thiol, okay? So you need to know that when there's cysteine, obviously there's a thiol, and the thiol undergoes oxidation, okay? So when we talk about oxidation, I mean, I wouldn't ask you how many, equivalents of oxygen and what's the product of these. These are like more chemistry stuff, okay? What you need to know is an oxidation that uses air or oxygen in the air, okay? To form the disulfide. And that's it for the top part. Why this is significant? Because this is one of the main detoxification or antioxidant activities we have in our body. Glutathione is an antioxidant, okay? An antioxidant is something that oxidizes with itself and reduces basically other stuff. Because when something oxidizes, on the other hand, it will reduce other things. And in the lecture, we talked also about that glutathione basically two molecules of these, because to form this one is basically two, right? It reacts with reactive oxygen species and free radicals, and also over-oxidized drugs, which is important in metabolomics. And that's it, okay? Now for GFP, we give this as an example, just to show you that the primary sequence of an amino acid, we talked a lot about its effect on the overall tertiary structure, right, and quaternary. But also to show that the sequence basically determines the activity also, all right? Because this color that forms by the reaction of these amino acids to form this chloroform is particular for this. That's why we don't fluoresce. You don't see us walking, with green stuff. So for this one, I wouldn't ask about the sequence, okay? Because this part, for this part, okay? For the rest of the class, it might be significant. So we are talking about structure, okay? Glutathione is very important, so you need to know it, because it's something that you're gonna experience and hear about a lot. But for this one, it's good if you remember it, but I wouldn't expect you to know the chemical transformation, okay? Or to memorize or the structure. But you need to know that there's certain amino acid sequence, and that particular amino acid sequence, not something else. If you switch it to put it like, if you put a phenylalanine maybe, or if you put an alanine, it's not going to form that kind of conjugation, okay? You need to know that some conjugation and a fluorophore results from this inside transformation. And to know that amino acid sequence is also important for function. So it could be an enzyme, it could be a carrier protein, it could be a structural protein like keratin, or it could also give you a function or something that that by itself, without the need of a substrate. And that's it, okay? But don't cram the structure, and don't expect you to know what the electrons and how the transformation is. Is this clear? Okay. So another question said that, can we go over question number 15 in the sample midterm? So before I answer this question, and this is something that I want to mention here, so sometimes there's difference in nomenclature, okay? Even like among two different textbooks. So sometimes you find something that we call it like I, sometimes called N. So when you see the two different like nomenclature, I'm going to explain it like soon. Don't assume it's a mistake or something wrong, okay? It depends on the person who's writing that particular book. So let's start first by reviewing what we talked about earlier, okay? And of course, I request you, or I ask you to follow the stuff that I presented, okay? The way I presented in the class is the stuff I'm going to ask you about. So we talked about the hydrogen bond within an alpha helix, or within a single polypeptide in the term of basically N interact with N plus 4. And what does that mean? We said that a peptide CO, so the carbonyl group of amino acid N, will form a hydrogen bond with an amino acid that's 4 residues far away from it, okay? And that will give you the best hydrogen bonding, okay? And we said that it doesn't matter, N could be 1, it could be 2, because it depends on its position in the sequence, okay? So let's assume if N is N, or 1. 1, this is to count how many amino acids, you either count the N, or the carbonyl, or the side chain. It's the same, right? Because every amino acid has these 3 constituents. So let's say that this is amino acid number 1, so you can count the side chains, the purple, for example, 1, 2, 3, 4. So you can see that N will form interaction with N plus 4, the NH. Okay? The NH on amino acid number 5, basically. Okay? Interacts with the carbonyl of amino acid number 1. So this is amino acid number 1, this is 2, this is 3, this is 4. Sorry, 1, 2, 3, 4, and 5. Okay? So 1 interacts with 5. So that's why if N is 1, N plus 1 plus 4 is 1. Okay? Is this clear over here?
Yeah.
Yeah.
Can you like just point what do they classify as term? Do they mean like the one term or?
Yeah, this is one. No, a term is different. This is one term. This one. Okay, and it corresponds to 3.5 amino acids. But the hydrogen bond is between 1 and 5. Let's say. All right. So, so now let's go back to the question that Dr. Russos asked in this exam. So in that particular book, or in that textbook, or the way he presented this, N is represented as I. Okay? But it's exactly the same. It would be I plus 4 or N plus 4. All right? So if we assume that I of the carbon is here, right? All right? What this will be? It forms hydrogen bond with N. N is at what position? The easiest way to count the side chains, right? Exactly, I plus 3, and that's the answer, okay? Or N plus 3. So basically, it's amino acid number 1 will interact with 1 at 4, okay? So total 4 amino acids, or the way you want to memorize it, okay? So this is N equal 1. 1 plus 3 is 4, right? So 1 should interact, 1 will interact with 1, 2, 3, 4, okay? The amine of amino acids 4 interacts with the carbonyl of amino acid 1. Is that clear? Okay? If this one is shifted, if you have another amino acid and it forms, will be N plus 4. Okay? If it forms with this one, N plus 2. But again, if I want to ask you a question, it will be N. I wouldn't ask you about the I. Okay? Yes?
Since you have the 310 split, are we supposed to also know about the 310 and the pi split?
No. Anything that we didn't cover will not use.
So it was on the last unit.
Anything we didn't talk about will not be covered. Okay? All right. So another thing about quaternary structure. For quaternary structure, we said that it's different polypeptide chains coming together. Okay? And we mentioned in the class, and we give an example of 2 proteins. One of them was transthyretin, and we said that every color represents a single peptide chain that folds into a 3-dimensional, 3-tertiary structure, and 4 of these comes together at the end and forms this native quaternary tetrameric structure. And we said there are no covalent interactions. And I want to clarify it here. When I mean no covalent, no peptide bonds, okay? So it's not like a peptide attached to each other. It could be ionic, it could be hydrogen, it could be hydrophobic, but sometimes also you see disulfide bonds, all right? Disulfides are covalent, but they are kind of special covalent bonds, okay? What happens here, the important difference between a disulfide with a tertiary structure is that the amino acid is continuous, it folds back, right? But these disulfides that forms in a quaternary structure, it will be a cysteine on this subunit and a cysteine on the other one that will form a disulfide. So if you reduce it, you're going to unfold it into still 4, okay? 4 subunits. So disulfide bonds could happen on quaternary structure, but you don't see a covalent bond, okay? That's why if you denature transthyretin and added some reducing agent, you're going to wind up with the 4 subunits separate, okay? However, if you have one tertiary structure, and remember, a tertiary structure is just one string of peptide, right? If that one has a disulfide bond, and you denature it, you're going to still have one peptide bond, right? Because the disulfide is within that amino acid. And that's what we need to bear. Is that clear? Or? Okay. Now, we have another question about basically